All right, today we are going to talk about relative frequency. And relative frequency is really just the probability of something happening times the total number of events that it happens in, right? So, looking at this first example, we have John flipping a coin. He's flipping a coin 60 times. We have the total number of events. All we need is the probability now. So, the probability of him are not really the probability, but the event happening. How many times did the event happen? I should say, not probability, because that probability would just be one half if it's a coin. But he actually does do it 60 times, right? So the event happened, and we're looking for it landed on tails, right? What is the relative frequency of it landed on tails? So it landed on tails 38 times. How did I know it's 38? Because I did 60 minus 22, right? If it lands on head 22 times, it has to land on tails 38 times. That's how I got that. Okay. So what is the relative frequency of it landing on tails? It would have to be 38 out of 60 times. And we could say 19 over 30 if we were simplifying it. And you could change that to percent. Of course, I didn't ask you to, but you can change it to 19 divided by 30, and then you will get your decimal, move it two places, you'll get a percent, right? We all know how to do that. Now, Sarah, she has a spinner labeled 1 through 6. Sarah spins the spinner 8 times and lands on an even number twice. She only lands on an even number twice. All right. So that tells you that 6 out of the 8 times she landed on an odd number, correct? So what is the relative frequency of Sarah landing on an odd number? So we know that we have 8 total times minus twice equals 6 times. Okay. So 6 times she landed on an odd number out of 8 would make it, we could reduce that to 3 over 4. Or we could say 75%. So what is the relative frequency of her landing on an odd number? 75%. Now, I will say once again, this is not your theoretical probability. This isn't saying, okay, how many times can she land on an odd or even number? Of course, that would just be 50% for both of them, right? Because you have the same even amount of numbers. What this is saying is we already did this thing 8 times, and she got this. So this is why it is called the relative frequency, because we're talking about in relationship to us already doing the events. All right, this is not regular probability. So please don't get these problems wrong, okay? Next, Drew rolls a die 24 times. So he rolled it 24 times. How many times can Drew expect to roll a number less than 3? Now, on these type of problems, we have not yet done the events. So this is basing it off of theoretical probability, right? In theory, how many times do you think this will happen? Not, oh, we already did it, and then let's count how many times or what's the relative probability. Okay. So Drew rolls a die 24 times. How many times can Drew expect to roll a number less than 3? So first off, we have to figure out how many numbers on a die are less than 3. We have 2 numbers, right? 1 and 2. 2 numbers less than 3. Okay. Now, what are the probability of rolling those 2 numbers? That is, of course, 2 over 6 or 1 over 3. Right? That's the probability of him rolling those numbers. Now, if we do it 24 times, what would be the probability? That's pretty much what this is saying. So we would say 1 over 3 times 24. And that would give us a total number of 8 times. Okay, so Drew can expect to roll a number less than 3 at least 8 times. See how these problems here are different from the problems at the beginning. These problems have not yet been operated yet, right? They are asking you for the exact probability of you doing this 24 times and get